Are you a DIYer or a machinist or a tinkerer or a mechanic that likes the idea of 3D printing but doesn't really know what's involved in the process? Well, stick around. Today we're going to design a simple part in a CAD program called Fusion 360. We're going to slice it up with a program called Prusa Slicer, and we're going to then print it on my Prusa Mini Plus printer.
I want you all to remember that I'm just another yokel who's not educated nor a professional in what I'm doing here, and it's possible that if you rely on this video, you, your project, or the both of you might end up as a smoldering hunk of hammered dog shit. Please use common sense, be careful, and always protect your ears, eyes, face, body, and hands when doing this type of work. With that, let's keep on trucking.
This video may contain peanuts.
Hey everybody, and welcome. I'm Werner, and today we're going to work on 3D printing some weights to go on my wheel adapter for my surface grinder. Recently we made a balancing jig and got everything set up in the wheel adapter and the balancing jig, but my wheel adapter doesn't have any weights on it for balancing. And while I could go and spend $340 on a brand new wheel adapter, I thought, well, first I will try to make my own weights and see if that would work. So how is this related to whether you should get into 3D printing or not? I'm not going to sit here and try to convince you by any means, because it's not for everybody, and I understand that. But what I'm going to do this time is I'm going to actually have you sit next to me while I design this little guy. This is one of my little wheel weights. Yeah, so I'm going to design that in CAD, excuse me, and I think it took 12 minutes, but you know, it's got four board holes, 3 of them threaded, and it's got an interesting shape, and it's got a ball bearing in there. And so I thought this would be an opportunity for others to just see what goes into doing a CAD design and then print it, 3D print it. So we'll walk through all of the steps, and it doesn't take very long. I find that for me, one of the best things about 3D printing is that I can make parts for around the house when I need to do repairs and I don't have time to wait for something to come in the mail, or perhaps there isn't a part that I can buy that will let me get the job done. You know, I can go and design it in CAD. So let me just share a small list of things that I've made, and I'll show you some pictures up here, and just to give you a feel for what's possible. So I've made a lot of tool holders, both for my drill bits and also for some of my taps and dies. I've made a holder for the DRO scale that goes on the quill for my vertical mill. Made a sink brush holder for the kitchen that's magnetic. And by the way, one of the most fantastic things about this is that you can stop your print mid-print, put a magnet into a hole that you've created in the design, and then start the print again, and it will print around the magnet and hold it in place for the life of the part. A candle holder. I made a tool holder for my 3D printer tools. A hook to keep the washing machine open. We got a new washing machine, and it was taller than our old one, and we couldn't open up the top door all the way. And instead of redoing the shelves in the laundry room, I just made a hook that goes around the shelf and then goes around the top of the washing machine lid and holds it up, and that was so much easier. Made a box fan holder for the window. Oh, and I also made a bunch of DI and DTI cases. Yeah, the digital indicator and digital test indicator cases. And those were fun, and it's way better than having them just floating around in the drawer. So yeah, I think the practicality of having a 3D printer is what's most important to me. It's, you know, I don't make little bobbly toys and stuff like that. I make things that I use every day. I'm sitting here at my workbench right now considering the best way to make some weights for this 2.25 inch arbor, wheel adapter that will go on my Brown Sharpe surface grinder. Now I held on to this adapter that I picked up on eBay just for a little bit longer. I'm going to have to return it because it's too large. But one thing that occurred to me, let's see how much one of these weighs. All right, so turn on this scale here, do it in grams, and what do we get? About 10 grams. All right, and then let's just see. I could use probably 1/4 inch, maybe 5/16 inch set screws as ballast if I were to 3D print some. So let's just see. How many of these do we need to get up to about 10? Well, reset it. Scale is kind of finicky. All right, that's all I have right now. That's 1, 2, 3, 4, 5, 6, 7. 7 of these to get up to 9 grams. So that's gonna be a pretty big weight. You know, if you had to squeeze 8 of those or 7 of those into an arc here and then have another 1 or 2. Maybe I don't need that much weight. I don't know yet. Maybe I'm going to have to make it out of metal. Those are the things I'm considering. I'm going to do a simple exercise just to see how many 5/16 set screws, socket head set screws, I might need in order to balance this, because I would use the set screws as ballast inside of a 3D printed holder. So right now the wheel's sitting on the balancing jig, and I'm just going to add a couple set screws to the heaviest point. Oops. And for now, just ignore the red lines. They're not necessarily the heaviest point. All right, it's still heavy on one side. So let's add some more. Another 2. Okay, now it's coming back this way. Okay, let's add another 2. We'll add them on the other side over there. All right, it still seems a little bit heavy somewhere. Okay, let's add one more of these up here. All right, this is starting to look like it might be balanced. And it took me 7 5/16 set screws to get there. And I'm doing this so I can estimate again the weight of the ballast that I will need in order to balance this wheel, because that comes into consideration when I'm making the weights. So I need 7, and I know that weighs about 8 grams. So, okay, I know where to go from here. So perhaps the best thing to do is just get some measurements on here, and then I can sketch it up in Fusion 360 and see whether, maybe I'll just 3D print a model and then go from there. So this external diameter is 1.934. The internal diameter here is 1.243, and the height is 0.293 inches. So with that, I should be able to sketch out some weights and go from there. I was about to fire off an order to Amazon for some 1/4-inch set screws when I remembered that I had this box of set screws from M2.5 up to M8 in various lengths. So this should be more than enough to help me make a balancing weight. Well, actually, all 3 balancing weights where I'm using the set screws as ballast. So yeah, we're going to give this a try. One of my goals in making these videos is to get other people excited about working in their shop and taking on projects. And most importantly, learning new things. I mean, that's what keeps our brain young. Thinking, researching, figuring out things. That's really important for mental longevity. But I don't mean to preach. I'm just telling you what I think. So I'm just going to walk through drawing out this little ballast weight for my wheel adapter, and let's just take it for a spin. So we're going to go ahead and create this weight, and I'm going to need 3 of them to mount on the wheel adapter, which holds the grinding wheel, so that we can balance out that whole unit for use on the surface grinder. So this is Fusion 360, and the way Fusion 360 works is that you sketch out the beginnings of your part in 2 dimensions, and then you do what they call extruding up into the 3rd dimension. So let's start sketching this out in 2 dimensions. Okay, we're going to choose our plane. Okay, this is now our sketching plane. We know that the ring on the wheel adapter has an outer diameter of 48.6 millimeters. It's actually just a little bit more, but we're going to make it a little bit smaller so that there's no interference when we install it. And then the inner diameter is going to be 31.37. All right, and then I want to make a line or a circle halfway between the 2, because we'll use that to lay out points where we will have some holes for putting in the ballast. So do another circle, and right now I'm just going to call it 40, but then we're going to go back and change it. So we're going to change this so that is equal to the average of these 2. So we say it's
48.6 plus 31.737 divided by 2. There we go, 39.985. So now we have, if you can imagine, these two areas, these two rings are the equivalent of the well that's in the wheel adapter where we will place the part, this weight. Okay, now let's draw some lines that delineate the edges of the weight. So I know that I want this to be 50 degrees of sweep. So I'm going to go up here and I'm going to put the angle, I want it to be 25 degrees from here, half of 50, but it measures angle from here. So we're going to call this 90 minus 25 degrees. And then I want the hole that will hold the ballast to be at 15 degrees. Okay, so we're going to call that 90 minus 15 degrees. And then we're going to do one last line up the center. And that's for mirroring. Okay, now instead of drawing these lines on the other side, we can just use a little shortcut called mirror. And we'll choose these two lines that we want to mirror. And then we have to select the line that we would like to mirror about. And so now it's created these two lines over here. Great. And lastly, we're going to put points where we want the ballast holes to be. All right, I think that's it. We can always go back and change it, so if it's not right, it's not the end of the world. Okay, the next step, we're going to turn this into 3 dimensions. And so we choose extrude up here, and we select the areas that we want to be extruded, and we want this thing to be 7 millimeters high. I'm going to go -7 and push it down, only because that keeps our sketch on the top surfaces, which is where we still need to work. There are other ways to do it, but just in this instance, that seems to be like a good idea to me. And I'm going to turn the sketch back on for now. Okay, the next thing that we're going to do is put in these 2 holes. So Fusion 360 has a tool for that. They call it the hole tool. And we're going to put in multiple holes. And we want it to be a hole without a taper at the top. We want it to be a threaded hole or a tapped hole. And we want the drill point to be flat. Okay, so once we place them, it'll give us some more options. So we want one here, and we want one here. And they're going to be the same. We want them to go all the way through. You can either choose to say it's 7 millimeters, but I just choose all the way through in case for some reason in the future we want to change the thickness of this part. It'll still drill the hole all the way through. Now this is already set up for what I want because I was working on this before, but we choose isometric profile threads, 6 millimeter hole, 6x1, 6H, and right hand. Really all you have to do is come up here and choose metric and 6, and it'll fill in the rest with what it thinks is the most likely. And in this case, it would be what it's selected here. Just so you can get a different view. Here you can see this is what it looks like now. So great, we'll hit OK. All right, we're probably what, 2/3 of the way there. We need to put this hole through from front to back where the ball bearing will sit that will be used to lock it into the groove. So let's work on that next. So I'm going to turn off this sketch here just to get it out of the way. And then we're going to make a new sketch, and we're going to do it on, I guess it's the XZ plane. The first one was on the XY plane. All right, so again, we're going to use our circle tool, and we're going to use it to bore these holes through the part. And let's see, since it's 7, let's see, won't be quite in the center. It doesn't really matter if it's in the center. Let's put it right here. And we're going to do a hole, one hole that's going to be just a little bit less than 4 millimeters. And we're going to put another one, oops, that's going to be just a little bit more. Okay, stop that. All right, let's bring it back up and look at what we've got here. Okay, we've got these two circles, and again, we're going to extrude them through the part. Now, extruding can mean adding material, but it also can mean cutting material, and that's what we're going to do this time. So the idea is that the majority of this hole is going to be 4.2 millimeters, so that the ball bearing can easily roll through it. But at the very end, we're going to make it 3.8 millimeters so the ball bearing can't fall out the end of the hole. So we'll start with the 3.8 millimeter part. We're going to extrude this center part, which is 3.8 millimeters, and we're just going to go up here until it goes through and see how it automatically changed from creating new material to cutting once it intersected the part. And we're just going to do that. That should be enough. That should be enough to hold it in place, 1 millimeter's worth of material. Okay, and then we're going to do the second part of the hole, the 4.2 millimeter part. And it has a tendency to turn off these sketches every once in a while, so I've just turned it back on. Okay, now I've chosen both parts of the hole. And I'm going to, again, run it all the way through, but we're going to call the distance all. But I don't want it to start until after that 1 millimeter of 3.8. So what I will do is I will change the beginning of the cut to an offset. So I want it to be offset 16 millimeters from the starting point. So you can see now it's starting 1 millimeter after this small part that's 3.86 millimeters. Okay. All right. And the last thing that we want to do is to put a threaded hole here. And when we screw that in, it's going to force the ball bearing out this hole and lock it into place inside of the groove. So let's do that. Let's first, instead of just eyeballing it, let's just make a little ball bearing. We're going to use the sphere tool, and we're going to do it here because that's in the same plane, and we're going to make a, let's get into that plane just so it's a little bit easier. We're going to go here, and we're going to make a 4 millimeter ball bearing. And then we're going to move the ball bearing into the hole to where it would naturally be sitting. Okay, let's try it like this. That's better. And I think I want it to be 17.5. That's a little too much. 17.4. Let's say 0.3. That's probably too much, but so let's go 4. Okay, that looks better. The last thing that we want to do is place a 6 millimeter threaded hole for a set screw that will go all the way through the piece. And the idea is that it will lock the bearing into place and hold it up against the ring in the wheel adapter so that this weight can't move anymore inside of the ring where it sits. Okay, so we need to first put a point here on this surface where the hole is going to go. So we'll start with a sketch. We're going to do the sketch on that surface. Zoom in a little bit. Okay. Problem is that we can't see where the bearing ends. Now, of course, I could measure it, but let's just keep this really simple. So I'm going to make this point again, and I'm going to hide the body of the part, but leave the bearing showing. Now we're still drawing on the surface of the part. So if I come here and zoom in and put my point right here, now we know where the edge of the ball bearing sits. Okay, so let's turn this back on. And we're dealing with a 5mm set screw. So therefore, let's go back actually to this same sketch, and we're going to put a point that is 2.75 millimeters up. All right, and now we're going to draw our hole. So we turn on the hole tool again, we select our point, and we have it go all the way through. What's going on here? We want it to be threaded, flat bottom. We want it to be 5 millimeters in diameter. Okay. All right, well that obviously wasn't right. I was just not thinking clearly. Before we go further, let's just rename these things really quick. We're going to call this the weight, and we'll call this the ball bearing. Okay, and somehow I determined that half of 5 was 2.75, but that's not correct. Silly me. So let's open up this sketch again, and we're going to change this from 2.75 to 2.25. There we go. Okay, and now the hole has also moved down to the new location of that point. And now we're done. So let's come here and we'll rotate around this. And that's about it. So what do we want to do next? The next thing is we want to 3D print this thing. So come over here to the weight and we right click on it and we say save this as a mesh. Then you get this little pop up here, exporting it. We're saving it as STL in millimeters. All that looks good, so we'll hit OK. And it's going to be called weight. We'll call it weight v1. Again, it's an STL file, and it's going to be actually saving it to my computer. Now, it will save in a file called workshop in the program, but here I'm saving it to my computer into the downloads file, or folder, excuse me. So we hit save. All right, now we've opened up my slicer program. Now, the slicer program essentially takes a three-dimensional part and draws the path that the 3D printer will run to make the part by excreting filament plastic layer by layer. So this represents the plate on which the part will be printed, and this is for my Prusa Mini, and we're going to import the part now, the STL file, which was this weight v1. There it is. You know, it's a small little thing, and it's sitting here on the bottom of on the plate. And we'll hit slice, and that basically generated the Gcode. That's the language that the printer uses to know where to go. So now we've made the G-code, and just so you can see what it looks like, let's zoom in a little bit down here. So this represents how the printer will be printing. So first thing it's going to do is lay out the surround, or the skirt they call it sometimes. And this is actually what the printer will be doing. The colors represent things up here in the upper left-hand corner, like perimeter, external perimeter. It's all going to be one color, the color that I choose, which is going to be black. So that's the very first layer. And you can see now this is adding each layer. And you can see, if you watch this circle here, you can see how it's hula hooping around because it's making the threads. So that changes. That circle changes so that there are actual threads in the piece. And again, at this point, I'll just show you, the black is the last layer, all the last layers, and again, just sweeping through here, this shows you what the printer is going to do on this layer. And finally, when it gets all the way up to here, that's when it's done. And so then what we do next is we determine how we want this printed. We say that we want each layer to be 0.15 millimeters thick. We want to use PETG. I'm using my Mini Plus printer. Don't need any supports, that's fine. That's something for the future. Let's move the infill up to 25%. I want it to have a little more rigidity so that the screws, or the set screws, don't cause the part to move around when inserted. And okay, then we hit slice again, and we're done. Here's something that this is changing, but in older printers, you have to copy the file, the G-code file, onto a thumb drive, walk the thumb drive over to the printer and insert it, and then it prints. Newer printers actually allow you to connect electronically via your Wi-Fi, but even as recently as 3 or 4 years ago when I bought this printer, you still had to walk it over by thumb drive. So now we're just going to export this file onto my thumb drive. And it says it's going to take 13 minutes to print. It's going to use 0.77 grams of filament for a total length of 1/4 of a meter. And it's going to cost me 2 cents to print this part based on the cost of the filament, which is about 20 bucks a spool, or 19 bucks a spool. Okay, so it's exported. So we just want to hit save it onto that drive. And then we're done. All right, so now we're done with this part, and we take the thumb drive over to the printer. So just walked over to the printer, flipping it on. Takes a moment to boot. Okay, put the USB card in there. And it actually brings up the last thing that was loaded onto the thumb drive. Hit print. And now we get to wait.
I've got our 3D printed parts here. 1, 2, 3. And they have their holes. And also, it's a little tricky to see. There we go. Anyway, so now I just need to install the hardware into these so that they actually have some weight. So I'll start with these 6mm. They're 6x6. Just threading them in. I actually started out with 6x10mm, and what happened was they were coming out of the top and it wouldn't allow the adapter to seat onto the surface grinder. So that required, you know, if going from 10 to 6, I lost 40% of the weight. And I hope that this is enough weight to actually balance the wheel. So now we're going to put the bearings in, the ball bearings. They're ball bearings. So we just drop it in there. Easier said than done. And then I'll just poke it down a little bit. And then we'll put in a set screw to help lock it into place. Okay, and as you can see here, when I'm here, it's just kind of hanging out there, but as I tighten it, it starts to come out and be proud of the hole, and it gets locked out there. And that puts a horizontal pressure onto the adapter and locks it into place. Locks the weight into place in the adapter. Okay, all right, now we've got these 3 little weights here. Let's see how much they weigh. Remember, the single weight from that other machine weighed 10 grams. Okay, so one of these, all done up, it's weighing in at 3 grams. Three of them weigh 9. So yep, 3 is a reasonable estimate. Now that's less than one of the weights on the other rig, and also these weights on this adapter are going to be closer to the center, so they're going to put less weight distribution or balancing weight into play. If they were further out, I think they would have a bigger impact. But we're going to try it anyway and see what happens. That's how we learn. Okay, that looks about the same. So I'm just going to put a little blue mark here just to remind us. Now that we have the hardware in the weights, let's go ahead and install them into the adapter. And I'll just start them out all at a 180 degrees. No, what is it? 120 degrees. Alright, and then I'll just tighten them up. See, right now they can slide. Then I tighten up this middle one, and it'll push the ball bearing into the inner wall, and it locks it up. Okay. So now it's up on the balancer again, balance stand, and it's got the weights installed, so let's see where it goes now. Well, it's still looking like it's pretty heavy in the same direction. So I'm going to just bring this weight up. Okay. Alright, what happens now? Okay, well, in case of an emergency, bring in a bigger tool. So I actually made a heavier weight with 4 sets of screws instead of 2. Let's see if I put this in here, if it's enough weight to help balance it. This is more fun than Mr. Toad's Wild Ride, as Jason Lee once said. I ended up going back and forth a few more times, and as you'll see, all of the weight is basically stacked up now on the light side of the wheel. But I think it finally is okay. That was quite an ordeal. Okay, I think we're good here. Ready to wrap things up here. We went through the whole process of designing and 3D printing a part, and now we're getting even closer to running the surface grinder. Right now even, I'm sitting here cleaning some parts, getting the rust off so I can actually read the dials. And I'm not sure if it's going to be the next video, but we're pretty close to getting that thing running and grinding some metal. You know, one thing, I don't usually ask for comments or anything else, but just for the sake of those who have not really used 3D printing in CAD, you know, people who have, you know, let other people know in the comments below what you think about 3D printing. Was it worth the investment of your time and your money? I think you know, more voices singing its praises are better than just mine. You know, but I love it. I can't get, I use this. This is the tool that I use more than anything else in my shop. And I'm so happy to have it. And I want a better one, but we'll get to that eventually. The Mini Plus is doing a great job, and it has for 4 years. Okay guys, well, as always, thank you. Looking forward to the next one. All right, so long for now.